Welcome to our video on what you do to one side, you do to the other. This video follows on from our setting out video, which supports the need to clearly set out step by step work in a structured, consistent way. In this instance, our setting out of algebra. It is important to understand that different mathematical topics may require us to set out differently. Always refer to your teacher's preferred setting out approach. Through clear and precise setting out, your teacher can clearly see which steps you have difficulty with or where your misconceptions lie. Through this algebraic example, we can clearly see our particular area where there may be errors, misconceptions, or a need for clarification. When your teacher says, "What we do to one side, we do to the other," often I hear, "I don't actually understand what that means." In this equation, you can clearly see that 3x plus 4 equals 34. That is the problem we have been given. We don't want to change that problem. We are simply trying to find the value of x through the process of backtracking with our order of operations, our mnemonic, BOMDAS or BODMAS. If you are still unsure of what this is, please check out the video for order of operations. So, all we are trying to do is isolate the 3x in order to find the value of x. Utilising this example, when we take away the 4 from the left side in order to isolate the 3x, if we don't take away the same value from the other side, our equation is no longer equal. It becomes not equal to. This is where we see very clearly why the equal sign is important. If we change one side of an equation, we must do the same to the other side in order to keep the balance. If you remember back to your primary days, you may remember using the scales. Where the right side value is 34, if the scales are balanced, that must mean whatever is on the other side is the same value. So in this instance, we know that 3x plus 4 is equal to 34. Therefore, our scales are balanced. But should we change one side of our equation, our scales will become unbalanced unless we do the same to both sides. This is where what we do to one side, we do to the other comes from. As you can see through the process here, what we did to one side we also did to the other, thereby keeping our equation balanced through backtracking in order to isolate the 3x, from which point we can then find the value of x. Hopefully this has clarified your understanding of what we do to one side, we do to the other.